Hey there. So you've been hearing all this buzz about large language models, right? ChatGPT, cloud, all that jazz. At first glance, it sounds like something straight out of science fiction, doesn't it? But trust me, once we break it down, it's way more fascinating and honestly, way less mysterious than you might think. What I love about this topic is we can skip all the brain melting math and complicated code because let's be real, unless you are actually building these things from scratch, you don't need all that nitty gritty. But knowing the basics, that can really help you get the most out of these powerful tools. Think about AI for a second. It's this massive umbrella term covering anything that makes machines do clever human like stuff. Spotting patterns, understanding language, making decisions. And under that big AI umbrella, you've got machine learning. This is where things get really interesting. You see, with traditional programming, we tell computers exactly what to do with tons of specific rules. But with machine learning, we just give the computer loads of examples and let it figure things out on its own. That shift completely changed the game. Now, within machine learning, there are these things called neural networks. And no, they're not actually tiny digital brains. They're just loosely inspired by how we thought human brains worked. In reality, they are just layers upon layers of tiny math problems, passing numbers around, constantly tweaking connections until they can recognize patterns. When you pile loads of these layers on top of each other, that's deep learning. And that's where our LLMs enter the picture. There's also this thing called reinforcement learning, where the AI basically learns by trying stuff out. Good move, it gets a virtual pat on the back. Bad move, a gentle slap on the wrist. These days, they often mix that with deep learning to make the latest LLMs even better. Remember how we used to have all these separate tools for language processing, tools for translation, tools for figuring out if text was happy or sad? Well, LLMs have pretty much waltzed in and taken over the whole show, writing essays, churning out code, explaining quantum physics, writing poetry. They're doing it all. 10 years ago, if you told someone a language model would be doing all this, they'd have laughed you out of the room. Yet here we are. So, what are these LLMs really? At their heart, they're just super clever neural networks. Not magic, not conscious, and definitely not plotting world domination, at least not yet. They are basically just really good at predicting the next word in a sentence. Think about your brain with all its neurons firing away. Artificial neural networks are similar in concept. They've got nodes, like mini computers, all connected and passing numbers around, adjusting things as data flows through. These connections have what we call weights, which decide how much influence one part has on another. During training, these weights get tweaked millions, even billions of times until the model gets really, really good at guessing what comes next. And the secret sauce in LLMs, it's this thing called the transformer architecture. It lets them process massive amounts of text super efficiently, all at the same time. The deep in deep learning just means loads of layers, not that they're having deep philosophical thoughts. Now, before an LLM can even think about sounding human, it needs a mountain of data to learn from. We're talking books, websites, conversations, basically anything they can get their digital hands on. But it can't just read raw text. First, it needs to break it down into smaller pieces called tokens. Think of tokens as chunks of text, could be whole words, bits of words, even short phrases. So a sentence like the cat sat on the mat becomes the cat sat on the mat. These tokens are the basic building blocks. And when you're talking to an LLM through an API, these tokens are what you're sending and receiving. Once you've got tokens, the model needs to understand the relationships between them. Since it works with numbers, these tokens get turned into vectors, basically points on this massive complicated map, where each word is a point. Words with similar meanings are close together on this map. Cat and kitten would be neighbors, while cat and income tax would be miles apart. Have you ever wondered how these models know which words in a sentence are the most important? That's where this amazing thing called the attention mechanism comes in. It's what lets the model focus on the most relevant words in context. Take a sentence like he sat on the bank and watched the river flow. Now, bank could mean a place for money or the side of a river, right? The attention mechanism looks at all the words at once and sees that river and flow are nearby, so it figures out we are talking about a river bank, not a financial institution. Pretty clever, isn't it? This attention mechanism was a huge breakthrough. It meant these models could process all the input tokens at the same time in each layer, which made training these huge models much faster and cheaper, especially with modern GPUs. And now we've got even fancier approaches like mixture of experts, where different parts of the model are specialists. So it only uses the bits it needs for a particular task. So, how do these LLMs actually learn to do all this clever stuff? Through a process called pre training, and it's basically a massive game of fill in the blanks. You show the model part of a sentence and it has to guess what comes next. At first, it's completely clueless, making wild guesses, but every time it gets it wrong, it gets a virtual slap on the wrist, and every time it gets it right, a virtual nod of approval. This happens billions of times until it gets really good at predicting. They even mask some of the words in the input to stop it from just cheating and memorizing. So, if it sees the cat is on the top, it might guess mat, table, or even roof. It's not just memorizing sentences, it's learning patterns. It figures out that cat is more likely to be followed by mat than, say, tax return. It does this by running the sentence through all those layers of mathematical functions, crunching numbers, and working out probabilities. Instead of just saying mat, it creates a list of possibilities with different likelihoods, like mat 55%, table 10%, and so on. Then it uses a function called softmatch to pick the most likely answer while still keeping other options in mind. But just guessing isn't enough. The model needs to learn from its mistakes. That's where backpropagation comes in. If it confidently says chainsaw instead of mat, backpropagation is like rewinding and figuring out which parts of the network led to that silly answer. The bits that caused the mistake get slightly adjusted, so it's less likely to happen again. And to make sure it doesn't go completely haywire, they use something called gradient descent, which helps it adjust just the right amount, like gently turning a steering wheel instead of yanking it. Training these things is a real balancing act. So, even though it's trained on tons of text, it's not just storing and memorizing it all. It's learning to understand the connections and patterns in the data. You could think of it like lossy compression. Like when you compress an image and it looks okay but has lost some detail. It squeezes enough information about the data into its parameters to be able to recreate a sort of fuzzy copy. That's why LLMs can sometimes sound right but get the facts wrong. They're essentially guessing to fill in the blanks in their knowledge. The magic of it all is that this simple goal, predict the next token, leads to a surprisingly deep understanding of language and the world. Get this, a massive model like Llama 370B might be trained on 10 to 100 terabytes of text, but all that gets squeezed down into a 140 gigabyte file. That's a massive compression. So they can't possibly memorize everything. They have to actually learn to understand and connect things. Sometimes they do memorize things that appear really often, like popular books or famous speeches, but mostly they're figuring things out on the fly. Now, you've got this super smart language model after all that pre training. Great. But here's the catch, it still doesn't really know how to talk to you properly. All that training data wasn't in the form of questions and answers. It saw books and articles, but it wasn't taught how to respond in a conversation. So if you ask it something specific, it might just give you a list of vaguely related things. To fix this, they do something called instruction tuning or supervised fine tuning. Instead of just feeding it raw text, they give it carefully put together examples of instructions and good responses. It's like teaching it how to actually follow directions. This makes it much better at answering questions properly and acting like a helpful assistant. But they are still not perfect. They might misunderstand you, give dodgy info, or just go off on a tangent. That's where reinforcement learning from human feedback, RLH, comes in. Humans look at different answers the AI gives and rank them. This feedback doesn't directly change the model, instead, it trains a separate system called a reward model. This reward model learns how to judge responses like a human would. Then, this reward model is used to further fine tune the original LLM. The AI makes responses, the reward model scores them, and the LLM learns to give answers that get higher scores. It's much easier for humans to rank a few options than to write perfect answers every time. This whole process makes the LLM more useful and less likely to go completely off the rails. Of course, there are still issues. They can pick up biases from their training data or the human feedback, make things up, or say things they shouldn't. Companies are constantly trying to fix this, adjusting how they talk about sensitive topics and filtering out bad information. But they are not perfect. They are just really good at guessing what sounds reasonable. So, the main takeaway: pre training makes the model smart, but instruction tuning and RLFA make it actually usable. Without those extra steps, it's just a giant text predictor. With them, it starts to feel like it actually understands you, mostly. Finally, once a model is trained, the process of actually using it to do things is called inference. That's when it generates responses to your questions or prompts. Now, this needs to be fast, especially for real world applications. No one wants to wait 5 minutes for an AI to reply, right? These models are massive, doing loads of calculations every time they generate a response. If they ran them the same way they were trained, they'd be super slow and expensive. That's why they use all sorts of clever tricks to speed things up, like making the model smaller or optimizing the calculations. So, training makes it smart, but inference optimizations make it actually usable. When you use ChatGPT or Cloud or any LLM through an API, that's inference in action, generating its output word by word, or rather, token by token. So there you have it. LLMs are these amazing tools predicting the next word based on what they've learned from a colossal amount of text. They fit into the bigger picture of AI and they transform data into these eerily human like responses. But at the end of the day, they're still just tools. Incredibly powerful tools, but tools nonetheless. Pretty wild journey from simple word prediction to systems that can write poetry and explain physics, isn't it? And we've only just scratched the surface of what these models can do and what they might be capable of in the future. So, next time you're chatting with an AI assistant, you'll have a better idea of what's happening behind the scenes. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share.